SpaceX just pulled off the ending nobody expected from Flight 13. Ship 40 returned from space, flipped upright above the Indian Ocean, touched down softly, and stayed in one piece. Then the real ordeal began. For approximately 24 days, a recovery team fought rougher seas while trying to guide a 52-meter spacecraft towards safer water. On August 18th, SpaceX said the vehicle had reached a location just off Christmas Island. Engineers were heading there to analyze it in calmer conditions before attempting to return it to Starbase. That last detail matters. Starship has been recovered from the open ocean, but SpaceX has not yet said it is back in Texas, on land, or ready to fly again. Still, this is the first time engineers can inspect an intact Starship that completed ascent, coast, re-entry, a landing flip, and a soft ocean touchdown. So what did Ship 40 survive? What can the hardware reveal? And does this move Starship closer to true reuse? This is SpaceX Investor. Flight 13 launched from Pad 2 at Starbase on July 24, 2026, at 5:51 p.m. Central Time. It was the second flight of the Starship and Super Heavy version 3 vehicles. Super Heavy ignited all 33 Raptor 3 engines, completed ascent, and separated through hot staging. The booster finished the high-thrust portion of its boostback burn with all 33 engines, but the burn ended early. It later attempted a landing burn and hit the Gulf hard. Ship 40 had a different outcome. All 6 Raptor engines completed the ascent burn, placing the ship on its planned suborbital trajectory. It deployed 20 Starlink version 3 satellites. SpaceX said every satellite communicated through radio and laser links, returned telemetry, and was expected to burn up roughly 20 minutes later. Ship 40 also reignited one Raptor in space. During re-entry, it tested the heat shield, flew a dynamic banking maneuver resembling a future return towards Starbase, and used its 4 flaps to reach the Indian Ocean landing zone. Then 3 engines relit, the ship flipped, and it came to rest intact. A soft splashdown is not automatically a recovery. Earlier Starship tests were designed mainly to send telemetry until the final seconds, after which the ocean could absorb the vehicle. Ship 40 changed the value of the ending because its structure remained together and visible above water. SpaceX described Flight 13 as providing its first critical views of an intact heat shield after re-entry. That turns the vehicle from a remote data source into a physical record of the flight. Telemetry can show temperatures, pressures, acceleration, and control commands at instrumented points. Recovered hardware lets engineers compare those signals with the real pattern of missing tiles, cracked material, warped metal, damaged seals, scorched edges, and loads around the flaps. It can also reveal damage nobody predicted, and therefore nobody instrumented. This is why the recovery matters, even if Ship 40 never flies again. The full-scale test article carried its evidence home, and the ocean operation preserved access to it, instead of allowing. SpaceX has not released a complete salvage playbook, so it is important not to invent one. What the company confirmed shows how difficult the job became. On August 7th, it said the recovery team was still working in the Indian Ocean, while conditions worsened and seas became increasingly rough. The goal was to guide the 52-meter, or roughly 171-foot, spacecraft toward port. Elon Musk said the outlook did not look good, although teams had obtained close-up photos of critical heat shield and engine regions. 11 days later, the story changed. SpaceX announced that Ship 40 had reached calmer water just off Christmas Island. Images show the vehicle floating horizontally, black heat shield tiles exposed, with support vessels nearby. Keeping an enormous stainless steel vehicle accessible at sea is a different problem from landing it. Waves, weather, buoyancy, lines, and safe attachment points all matter. The surprise is not that the operation took weeks. It is that a ship never designed as a boat remained useful long enough for engineers to reach it. The heat shield is the most obvious prize. Starship has thousands of ceramic tiles protecting the side that faces the hottest re-entry flow. Flight 13 also banked to resemble the path of a future Starbase return. Engineers can compare predicted heating with the actual condition of tiles, gaps, attachment points, edges, and flap interfaces. A missing tile does not automatically mean the design failed. Location and timing matter. A tile lost after peak heating is different from one lost early, while a scorched surface may have performed as intended. The useful question is whether protected structure remained inside temperature and strength limits with enough margin for repeated flight. Recovered hardware can map local damage back to time-stamped data and onboard video. Investigators must also separate atmospheric effects from splashdown damage and 24 days of saltwater. SpaceX has not published that inspection. Until it does, photographs prove the ship survived. They do not explain why it survived, which components need changes, or how close the margins were. The same logic extends beyond the tiles. Ship 40 completed a 6-engine ascent, restarted one Raptor in space, and relit all 3 sea-level engines for landing. Engineers could inspect plumbing, engine bays, shielding, seals, actuators, welds, and mounts after those phases. The flaps controlled descent and guided the ship toward its landing zone. Physical examination can reveal bearing wear, hinge loads, heating, deformation, and damage around moving interfaces. The airframe may show how loads traveled through rings, weld seams, tanks, and bulkheads during the flip and touchdown. Even the payload door can be checked against the flight record. But the ocean adds new damage. Salt enters openings, corrodes exposed parts, contaminates systems, and complicates electronics. Investigators must distinguish flight damage, splashdown loads, towing loads, and seawater exposure. That separation is why SpaceX wanted engineers working in calmer water before attempting the long return to Starbase. The images can make this look like reusability has arrived. It has not. Ship 40 did not land on a pad, return to a tower, receive a rapid inspection, refuel, and fly again. SpaceX has not announced a plan to refly it. Ocean recovery is a forensic operation, not a repeatable transportation system. Starship's economic promise depends on routine flights. A reusable ship must survive re-entry with limited repair, return to a controlled site, be handled safely, and launch again on a predictable schedule. Every extra day, vessel, crane, inspection, tile, or engine change adds cost and time. Flight 13 proved a narrower but important point. The ship can complete the mission profile, control its descent, perform the flip and burn, and remain intact after soft splashdown. The salvage preserved evidence needed to improve later vehicles. That reduces technical uncertainty, but it does not reduce turnaround time yet. Celebrate the milestone without confusing a one-time rescue with the operating model SpaceX ultimately needs. Think of Starship reuse as a ladder. The first rung is controlled re-entry. The second is accurate guidance. The third is a stable flip and landing burn. The fourth is surviving touchdown in inspectable condition. Ship 40 climbed all 4 over the ocean. The next rungs are harder. Return towards Starbase, land or be caught safely, move into inspection, repair only what is economical, and refly. One success is not enough, because heating and vehicle loads vary. The system must repeat across multiple ships and conditions. Flight cadence matters too. SpaceX needs enough launches to learn quickly without turning every mission into a rescue campaign. Physical access to Ship 40 can shorten that loop. An engineer can connect a temperature trace to a tile gap or a flap load spike to visible deformation. Teams can then change hardware, manufacturing, inspection, or flight software before another attempt. That is the strategic value of recovery. Better information arrives before the program asks the next vehicle to do more. For investors, the recovery matters because it attacks technical uncertainty. Starship is central to plans for larger Starlink satellites, high launch cadence, orbital refilling, lunar missions, and eventually Mars. Those businesses require a ship that returns reliably. An intact article gives SpaceX richer data for improving reliability and estimating refurbishment. It can influence design, tooling, tile installation, engine protection, and inspection systems. But the recovery also exposes the distance between development and mature service. A team, support vessels, weeks of work, and a remote location preserved one test vehicle. We do not know the cost, what hardware remains usable, or which parts fail inspection. The bullish signal is that the ship survived enough punishment to be studied. The risk signal is that routine reuse still depends on unproven steps after splashdown. The metric is not whether Ship 40 looks dramatic beside Christmas Island. It is whether its lessons make later ships land more precisely, need less repair, and return to flight faster. Here is what to watch next. First, confirmation that Ship 40 is secured and can return to Starbase. Second, any company release showing tile retention, flap condition, engines, or structural findings. Third, design changes on later ships that match what engineers found. Fourth, another intact return proving Flight 13 was repeatable. And finally, a controlled Starbase recovery followed by evidence of inspection time, refurbishment, and reflight. As of this recording, SpaceX has not published an official Flight 14 date or confirmed a tower catch attempt. So rumor is not schedule. The verified story is already strong. Ship 40 launched July 24th, completed the in-space demonstrations, survived re-entry, splashed down intact, endured approximately 24 days at sea, and reached calmer water off Christmas Island. That is not rapid reuse. It is something more useful than a headline, a spacecraft-sized answer sheet for engineers building the next version. Subscribe for every verified recovery milestone. This is SpaceX Investor.